TheTokener explains, a beginner's guide to developing smart contracts using the Solidity programming language on top of the Ethereum blockchain platform. In this episode, we will talk about mappings. Mappings are one of the few data types that are built into Solidity that we did not cover yet, and they are very, very useful, and they occur almost in all non-trivial smart contracts because they allow you to find information given a key, and what type this key has doesn't matter. So if that's still a bit vague, let me tell you in a little bit more detail what it is. It's a key value store. Now, if you use an array, of course, you can store values inside given an index. And this index however, has to be an integer and it has to be consecutive. And that's a problem if, for instance, we want to store balances of any Ethereum address and balance in tokens or something. So we can find out how much money certain people have on the blockchain. So that's what the mapping is used for. We can, for instance, create a mapping of address to integer, and then we can later on find for any address how much for that address was stored in this mapping. So this is a data type also known in the more abstract way as a dictionary. So you might have heard that name before in different programming languages. And it's very similar to the concept of an associative array or a hash map. However, these last two usually are able to know how many values are actually stored inside, how many keys are currently taken. And the mapping does not have the concept, doesn't know the difference between a key that's taken and the key that's still empty. So you can't get this information. So this is very important to note. Mappings do not know the difference between something that wasn't yet filled and something that has the default 0 value, which is of course 0 for numeric types and the empty string for a string and things like that. So you have to be aware of this. If you store your own custom data types inside, you might want to write your data type in such a way that it has a special case that shows that it's still uninitialized, or so still empty, unused. So you can have both the case where it's not filled in yet and the case where it's empty or 0. So how to use a mapping? Oh yes, we will get to that soon. But first, when are they actually used in practice? So as I told in a couple of slides ago already, they're used when we want to find the balance of a given address, which is used a lot on the Ethereum blockchain, but also if we want to store other information that relates to an address, such as settings or say a username. But of course, there are also other kinds of nested information that we would like to keep track of. For instance, we would like to find content given the titles of some posts. If someone writes articles and we want to store those articles on the blockchain. So then if you only have the title, we can find back the given post again if it exists. Or for instance, the Ethereum domain name system also uses this to find if a certain domain name is already taken or not. And of course, if it is taken, then whom it belongs to. So in those kinds of situations, mappings are used. Now let's look at how you can actually use it in your own smart contracts, what code you have to write to use it. So when we define a mapping, we use this syntax for the typing. So we say we want a mapping, and then between parentheses, we say the type of the key, and then we have a fat arrow, and then the type of the value. And if we want to add something to a mapping, we use the syntax given here and indicate the key over here. So this is very similar as when indexing into an array, but here we do it in a mapping. And when we just want to look up the value, then we don't add an equal sign behind it with a new value. We just we only refer to the given key inside of the mapping. So this looks very similar to what you've seen previously. This is probably the only really different thing that's different from before. And now let's look at some interesting example on Remix and try this out ourselves. So here we go. Let's write a new smart contract. If you still have the contracts open from previous episodes, feel free to close them. Of course, you might want to save them. You might want to save them first, and create a new smart contract. What we're going to build today is something where any person that has a Solidity address is able to store their favorite word. So we will call this contract one second. Favorite word dot sol. There we go. So first let's write the pragma Solidity again. So we restrict our source code to this version of Solidity, and then let's start the contract. Contract favorite word, and inside of here we want to keep track of one thing, because it's a very simple smart contract. We want to keep track of what words were actually already stored inside. Mapping, and this will be a mapping of address to string, because words are stored in a string. And let's just call this words as well, because it seems like a very descriptive name. So there's still an error here because I missed an S. There we go. So now we want to be able to store new words in there, but of course you're only allowed to store the word of your own address, and we want to be able to read the word of yourself or also someone else. So let's say how we store a word. We will write a function for that. Function store favorite word. It's called store. That's descriptive enough, because we already know that this smart contract is called favorite word. And we will take the new word as parameter, string word. And in here we will say that inside words, at the location given by message.sender, which is the address of the person executing this function call, will become the word that was passed in. Now, of course, we get a warning here. What is the warning? No visibility specified. We want to say this is public, because anyone is able to call this. So anyone outside of the smart contract is allowed to call this. And now to find out what word someone stored previously, we will write a function word of or find address, and this function will also be public, and we can specify that this is a view function, because it will only use the data of the smart contract and not modify it. And we will return a string, namely the word of the person. And in here, oh, it already automatically inserted an extra curly brace for me. Here we will say words person, and return this value. So here we go. We can compile this. It already is on auto compile in my case, so we'll just compile it. Then make sure that we're in the JavaScript VM environment, because it makes testing easy. And then let's deploy our smart contract. Now we have two calls that we are able to do. First, for our current account here, let me move this a little bit, and we have a nice button over there to copy the address value. Let's store a word here. Of course, in my case, my favorite word is Resilia, which is the name of my company. Let's store it. And Remix expects you to put quotation marks around string arguments when you execute it in the interface. So let's try again. There we go. That succeeded. And now if we were to insert our address, which is this over here, and we can get the value by copying it, then when we use that address and we press find, then we find the result here. Now let's try it once more for another account. So because we now selected this account, if we store another word in here, TheTokener, of course, again with the quotation marks, here we go. Now if we were to use this one, we will find that the string of this account is TheTokener. And if we go back to the previous account, copy that value, doesn't matter then which account we're on, because this only uses the address that's passed in as a parameter, we will find out that the string still, in this case, is Brasilia. So that's a very simple example, but I hope it gives you some clarity on how you can use mappings and how they're used in practice. There we go. That was everything for this episode. Thank you for watching this episode of TheTokener Explains. Like, subscribe, and tell us in the comment section what you think of this episode, or any questions you might have. Also, check out the show notes page, which we will keep up to date even when new versions of Solidity are released. Oh, and you should definitely ring the notification bell to make sure that you will know right away when a new episode of TheTokener Explains appears. TheTokener Explains is a collaboration between TheTokener and Brasilia. If you are interested in the latest cryptocurrency-related information and news, you should go to thetokener.com. And if you are currently building your own blockchain-related product